Hello, everyone. Welcome back. So today we are going to continue on with our arithmetic sequences. Now, just a reminder, this is the second video in the series. If you'd like to know how we started off, please go back and watch lesson 1 of the series, as this is lesson 2. This time we're going to be talking about the general term, and also we're going to be talking about the recursive formula. So previously, we noted how in this case, the 40th term is negative 91. But what if I want a formula for the general term of the series, right? Or the sequence, I should say. Sorry, not the series, the sequence. Well, the general term is just what is t of n in general? Well, t of n in general is going to be 65, right? 65, so the first term, plus n minus 1 times d, which is negative 4, okay? So this is the formula right here for our general term of the sequence. So if I wanted to know what's term 10, all I have to do is plug in n into two spots and solve, and then we're done, right? Or if I wanted to find out what's the millionth term of this sequence, then all I would have to do again is just plug a million into n in both spaces, solve, and then we're done. And so this formula here tells us the general term, right? Because the first term of the sequence, it never changes. It's always 65 in this case. Same with the common difference, it never changes. It's always negative 4 every single time in this case, right? The only thing that changes is the term we're finding, right? Are we finding the 40th term? Are we finding the millionth term? Are we finding the 5th term? Are we finding the 10th term, right? Which term exactly is it that we're finding, right? That's what changes. That's what changes. And that's the purpose of having this general term. So if you're ever asked to write the general term, it's the same formula we use to find a specific term, except because it's the general term and they're not specifying which term, we can leave n out because n is what we don't know exactly. Okay, very good. All right, this next one's a little bit trickier. This one says determine the number of terms in this sequence. So what we're going to do for this one is I'm first going to write down, well, what is it that we know? So there's four elements. There's Tn, there's n, there's the difference, and there's T1, right, which is our first term. So we do know our first term, that it's 6. We also know, we don't know the number of terms, so it's n that we don't know. They're saying determine the number of terms, so that gives us a hint that that's what we don't know, that's what we're trying to figure out. D, the common difference, we can easily realize is 3, right? 6 plus 3 is 9, 9 plus 3 is 12, and so on. So the common difference is positive 3. And then T of n, well, we don't know how many terms are in the sequence. However, we know that T of n, the last term, is 372. And since we want to know the full number of terms in this sequence, T of n we're going to set to be the very last term, because we'd like to know what is n in this case? How many terms are there from the first term to the nth term, right? And so that's why we know that T of n is 372. So in this case, it might seem like, oh, we don't have enough information because we don't know what, some people might not realize that we actually do know what T of n is. It's pretty straightforward to know that T of 1 is 6 and that D is 3, but we do know that T of n is 372, even though we don't know what n is equal to, because we know that that's the number of terms we're counting. We're counting from that first term to the nth term, right? The last term is the nth term in this case, which we know is 372. So in this situation, we know what T of n is without even knowing what n is, which is a little bit different, something we haven't done yet. Okay, so in this situation, the nth term is the last term, or really any time you're being asked to determine the number of terms and you have that last term, the last term is the nth term in that situation. Okay, so let's figure this out then. So we know that T of n is equal to the first term plus n minus 1 times d, right? We know that's our equation. Now let's plug in our numbers. So we know T of n is 372. That's equal to 6 plus n minus 1 times d, which is 3. Now let's remember, we need to remember here to use the distributive property and distribute this 3 here and here. Okay, so our next line will be 372 is equal to 6 plus 3n minus 3, right? Because I multiplied this 3 by n. 3 times n is 3n. I also multiplied the 3 by the negative 1. So 3 times negative 1 is negative 3. My next step, I'm going to subtract the 6 and the 3 with each other. So 6 minus 3 is 3. So here I'm going to have 3 plus 3n is equal to 372. Then I'm going to move the 3 on the other side, and we're going to get 369 is equal to 3n. So therefore, n is equal to 369 divided by 3, which means n is what? Let's grab our calculator. 369 divided by 3, which we do know is divisible by 3 from our rules, but let's figure it out. It's 123. Very good. So therefore, there are 123 terms in the sequence. So this is similar to the other questions, except instead of being given n and not being given what the nth term is, in this case we're given, here's the nth term, right? It's because it's the last term, so here's the nth term. But what is n? How many terms are there exactly throughout all of this, from the first term to that very last term, that very nth term? All right, very good. Here it says, given the arithmetic sequence, find the missing terms, and B, find the recursive formula. So I'll go over recursive formula after, but first let's find the missing terms. So we know that the first term is 10, and we know that the last term is 166, and we know that we're going to be adding the same common difference. So 10 plus the common difference, plus D, plus D, plus D, plus D, is going to get us to 166. So what we know from this, given what we know about arithmetic sequences, we know that 10 plus 4D, right, we're adding D 4 times the 10, is going to equal 166. So from this equation we just made together, we're going to be able to figure out what is D, right? What is the common difference? And once we know the common difference, we can easily fill in this one. In this one, when we're asked to find the missing terms, and there's so few terms, there's not really much of a shortcut we're supposed to take. They really do want all the terms, and there are only 3 of them to give, so it's not too difficult. They're never going to ask you to find, to fill in like 100 terms or something like that, right? If that's what you think is necessary to answer a question, then likely there's a simpler way of doing it. But in this case, we really will just fill in all the terms because there are only 3 of them. So in that case, that is what they mean for us to do. Okay, so 4D is equal to 156, which means D is equal to 156 divided by 4, which is 39. So now that we know 39 is our difference, all we need to do is take 10 and add 39, and take that number and add 39, and so on. So 10 plus 39 is 49. 49 plus 39 is 88. 88 plus 39 is 127. And then when we add 39 again, we should get 166 if we do it correct. And we do. If we add 39 again, we do get 166. Now, let's say we didn't. That would mean that our common difference is not correct, right? Because we know that we need to make sure that that when we add this difference, when we add 39 to 10 4 times, we end up with 166. We end up with our end number. Okay, so that's how we would solve that. Now let's talk about the recursive formula. So actually, I feel that the recursive formula is a bit less useful than the other formula we learned, but we will still learn the recursive formula. It is still a good formula to know and to understand, and it is important in the sense that it does accurately describe how the arithmetic series and sequences work. So basically, t of n, the nth term, is equal to t of n minus 1 plus d is the recursive formula as a general rule, right? So we're going to, we'll show this with the recursive formula in a moment here, but for now I just want to talk about what this formula is really saying in English terms. So t of n is saying the nth term is equal to the previous term plus the difference. plus the common difference, which makes sense. No matter what term I choose, if I choose 49, 49 is equal to the previous term, which is 10, plus the common difference, which is 49, right? Or 39, sorry. So 10 plus 39 gives us 49. If I choose 127, it is true, right? 127 is equal to the previous term, which is 88, plus the common difference, 39. And so this recursive formula makes complete sense with what we know about arithmetic sequences. So this recursive formula is a new formula for us. However, it doesn't necessarily tell us something that we didn't already know, right? Because we at this point we already knew that one characteristic of the arithmetic sequence is that any given term is equal to the last term plus the difference. The reason I say that this one might not be as useful for solving in general is because in this situation, we would have to know the previous term in order to get the next, right? So for example, if I want the 100th term and I only tell you the first 5 terms, well, this formula would just tell us that the 100th term is equal to the 99th term plus the difference. But the problem is we don't know the 99th term. So, okay, let's use this formula to find the 99th term. Okay, so then the 99th term is equal to the 98th term plus the difference. Oh, well, we don't know the 98th term. Okay, so let's find that then. The 98th term is equal to the 97th term plus the difference. But we don't know the 97th term. So I think you get the picture at this point that we would have to use this formula close to 100 times in order to figure it out. Whereas with the previous formula, we could just go straight to what is the 100th term, which is the actual question, without having to then find the 99th term first, then realize that to find that one with this formula, we need the 98th term, which means we need the 97th term, which means we need the 96th term, etc. And so we really would just end up using this formula to create that list, right? To go from whatever the highest term we know is, and just add the difference a whole bunch of times in order to get the 100th term. And so that's why I say that this formula isn't necessarily that useful in terms of solving certain equations, and it doesn't necessarily really give us a lot of information that we didn't already know in English terms, right? Because we already knew that to find any term in the arithmetic series or sequence, we could take the previous term and just add the difference one more time and that we would get there, right? That's something we did already know. Very good. Very good. So that is the recursive formula. In this case, we do know that the nth term, if we're going with the last term, is going to be, if we want to do this in general, we don't know what t of n is or what tn minus 1 is, but we do know that the common difference is 39. So this could be our just our general recursive formula. We can also use this formula to give true facts. So I could say 88 is equal to 49 plus 39, or I could say 166 is equal to 127 plus 39, or other things like that. But that's not what they're asking for in the question. Those are just things we can do with it. What they really would like to know is this, right? So all we really need to plug in is that difference, because the difference never changes. Whereas t of n and t of n minus 1, all that's talking about is any term and then the term previous to it, right? I guess the only thing we couldn't put in here is t of 1, because then there wouldn't be a previous term, right? The first term is the only term that doesn't have a previous term, but every other term, including the last one, does have a previous term. So as long as we know the first term and the difference, we can use this to kind of build stuff up. All right, very good. All right, so here is some solving arithmetic sequences using systems of equations homework. I'm going to go through a couple of these examples, and there is a answer key here to check. I'm not going to go through every single example because, again, I encourage you to do this for homework, but I am going to go through A and B today in the class. I think that'll be really useful and give us a start. And also too, we didn't do any questions exactly like this today. We did some similar, but nothing exactly like this. So I do want to go through how we would approach something like this. So it says determine A and D for each sequence. So A actually is the same thing as t of 1. We've been saying t of 1 rather than A. I just find that easier, right? If we're going to use the t of n, then t1 would just be the same as the first. So t1 and D is what they're really looking for in this. Now here in A, they gave us that t11 is equal to 65 and that t of 210 is equal to 1,458. And then in example B, they gave us that t of 5 is equal to negative 30. So fifth term is negative 30. And t of 150, the 150th term, is equal to negative 1,190. So they didn't really give us a lot of information. All they told us is two different terms in the sequence. And so it kind of seems as though they didn't give us enough information to solve this kind of question, but they actually did. And I'm going to explain how in a minute. That said, though, I do encourage everybody to give this a try for themselves first. And then once you have, once you've given it a try, if you get stuck, then feel free to come on back. But I do encourage you to try this one on your own first. Okay, so with that said, let's go ahead and do it. Let's do A. So basically, for A, what is given? We know that t of 11 equals to 65, and we know that t of 210 is equal to 1,458. So we're going to basically use systems of equations to solve this, right? We're going to have two equations and we're going to have two unknowns, okay? So we know what? We know that, let's see. We know that t of n is equal to what? Is equal to the first term plus n minus 1 times d, right? So therefore we know that t of n, right, 1,458 is equal to the first term plus n minus 1, which in this case n is 210, right? 210 minus 1, which is 209 times d. So we know that 1,458 equals t1 plus 209d. So that's our first equation. I'm going to mark it here. This is our golden equation 1. Then how about equation 2? Well, equation 2 is that we know that 65 is equal to t1, so our first term, plus 11 minus 1d, which is 10d, right? So 65 equals t1 plus 10d, and that's our equation 2. Okay. So now we have two equations and we have two unknowns, and so we are able to solve this, which is fantastic. Now, if you're looking at this and you're thinking, I have no idea where do we go from here? How would we actually solve this? We still have two unknowns. No worries. There is actually a video in the grade 10 series reviewing those, how to use substitution and elimination, which are the most common methods for solving systems of equations that are like this, in this kind of form where we have two equations and two unknowns. So I will link that below. In order to help out if that's the case. But in this situation, I'm going to use elimination. However, substitution will work just as well too. It'll just maybe take a couple more steps. So let's do that. Let's use elimination. I'm going to put these equations right next to one another. And here we have 65 equals t1 plus 10d. All right, so now I'm going to subtract this one. And why am I subtracting? Just a reminder, it's because t1 subtract t1 gives us 0, so that eliminates a variable. So that way we'll only have one unknown, which is going to be d. And once we figure out d, we can just plug it back into either of the two equations above and find out what t1 is, right? And so therefore it's going to be very straightforward from there. So what is 1,458 subtract 65? Well, I'm not sure. Let's see in our calculator. It's 1,393, and that's going to equal t1 minus t1, which is 0. So I'm going to put a big 0 there. Plus, let's see, 209 subtract 10d. Well, that's going to be 199d. So 199d is equal to 1,393, which means if we divide this by 199, we're going to end up with d is equal to 7. So that means our common difference is 7. Now that we have that, we can find out what t1 is. T1 is equal to Let's see. Well, actually, let's plug it into equation 2. It'll work. Now, I want to clarify. It'll work whether we plug it into equation 1 or equation 2. The reason I am choosing equation 2 here is just because it looks like a equation with smaller numbers, so it'll be faster. 65 equals t1 plus 10d, which we know d is 7. So 65 equals t1 plus 70, which means t1 is equal to negative 5. And that is the answer they got here, except of course T1 they said was A, but it's the same thing. So you should have gotten that T1 or A is negative 5 and D is 7, and that is indeed what we got, so we've done it correctly. So if the solving part was difficult, if from here down, say, if this was the difficult part, then I strongly suggest going back to review substitution and elimination, and I'll put video links for that down below. But if the trouble was this part here, then this part, going back to those videos, won't help us with this part. This part is just us putting in the information we know using the general term formula. So that first formula we learned in the last video. All right, that said, let's move on to B next. Let's do B. And then the rest of these I will leave for you as homework. I'm not going to do all the homework for you, but I will give you the answers. You stuck around this long. I will give the answers to the first two, and not just the answers, but the solutions, because you do already have all the answers, just not all the solutions necessarily. Okay, so let's do B. So for B, we know that the fifth term is negative 30, and the 150th term is negative 1,190. Okay, well, right away that tells me that D is going to be negative here, because we're starting with, in the very beginning of the, well, not the very beginning, but near the beginning of this sequence, we have negative 30, and then we have a much more negative number a lot further down the road. So that tells me right away that our difference is going to be a negative number. Okay, but let's go ahead and put this in. So what do we know? We know that t of 5, or negative 30, is going to be equal to the first term, t1, which we don't know, plus n minus 1, which is going to be 5 minus 1, times d. That means negative 30 is equal to 4d plus t1. Okay, so that's our first equation here, is this one. So I'm going to box it in just to remind ourselves this is, our first major step here. Our second major step is to say 1,190 is equal to T1, so the very first term in this sequence, plus 150 minus 1 times D, which again we don't know D. So that means negative 1,190 is going to be equal to 149d plus t1. And that is our second equation. Okay, now we're going to subtract the two. So we have negative 30, negative 1190. Then we have 4d, 149, no, not 14d, sorry, 149d, and plus t1, plus t1. So I'm going to use elimination again. Even though substitution would also work, it would just require us to rearrange things a little bit here. So if you do prefer substitution, you can go for it. I'm an elimination person whenever I can, so I'm going to do elimination. And it is faster to do elimination here, I would argue, as well, because we already have a t1 in both equations, and so it's very quick and easy to do that. Okay, so negative 30 minus negative 1,190, well, that's going to be a positive number. That's going to actually give us positive 1,160, because we're doing negative 30 and then plus 1,190, since the two negatives together make a positive. Then we have 4 subtract 149, which is negative 145d. And then we have t1 minus t1, which is just 0, which that's good. If we didn't get a 0 there, then perhaps we didn't subtract the right stuff. Alrighty, so now I'm going to divide by negative 145 on both sides in order to solve and find out that d is 8. Oh, and by the way, something I should mention. So, I mean, in these examples, most of them actually aren't going to be decimals, but D can be a decimal and so can A. It is possible in certain situations for the first term to be a decimal number and for the common difference to be a decimal number or a fraction. It does not always have to be whole numbers, even if some of the terms are. Now, if you get a very super crazy decimal and the numbers you're given are just, numbers that are integers, then that may be a mistake. But if you're just getting, some simple fractions of, a quarter or a half or an eighth or something like that, you're probably okay. There are some fraction decimal answers. Okay, that was a bit of a side note though. Back to this question. We found out that D is 8, so now we need to find out what T1 is. So we have negative 30 equals to 4D, which we know that 4D is 4 times 8 plus T1. So that means that we have negative 30 equals 32 plus T1, which means that T1 or A is going to be negative 62. Oh, did I do that correctly? I feel like that wasn't the answer we were supposed to get. No, the answer we were supposed to get is that that D is negative 8. Okay. My apologies. I divided 1,160 by negative 145. I said positive 8. It should have been negative 8, which makes complete sense here as well. Then we're going to get 2 here for T1. Okay, mystery solved. So T1 is supposed to be 2 or A. It's, same thing. And so we're good to go there. All right. So that's the first two solutions there. Best of luck with the rest of the homework. There's still C, D, E, F, G, and H to go ahead and try. However, that said, it's, these questions are all very much the same. It's the same method for all of them, which is pretty good. But yeah, that is it for arithmetic sequences. Next time we'll talk about an arithmetic series and how arithmetic series are different from arithmetic sequences, and we will go from there. But yeah, have a great rest of your day, and that's all I have for you today. Bye for now.